Hello everyone, welcome to this session. Chapter is Newton's laws of motion. So far in our previous video, we started discussing the first Newton's law of motion. So today let's move on to the Newton's second law of motion. So in this, we'll start with the concept of the linear momentum. So the second Newton's law of motion always involves this linear momentum. Now we'll start with the concept of this linear momentum. The linear momentum, this is just one of the important aspects used to explain the motion of a body in a straight line. Linear momentum is obtained as the product of mass and velocity. So linear momentum equals to mass times velocity. So that's the linear momentum. Now a body with a larger mass and the one with the smaller mass will simply possess different amounts of momentum when moving with the same velocity because of their masses. Now, a body with the smaller mass, it can be stopped easily compared to the one with the larger mass. So that's the case of the linear momentum. Now, that is to say, the larger mass bodies, they possess this larger or large momentum than or just compared to the smaller mass bodies. As you can see, their difference in terms of the mass, so it also result in difference in momentum. Now, linear momentum has both magnitude and direction. So linear momentum, this is a vector quantity. The SI unit of linear momentum is simply the combination of the individual SI units of mass and the velocity, that is kilogram meter per second. So that's the linear momentum. Now, therefore, the SI unit of linear momentum is this kilogram meter per second, as you can see. Now, the linear momentum is determined by measuring the mass of the body and its velocity, as we said before. A body with a larger mass and moving with higher velocity possesses larger momentum. So that's how it is. And a body with the lower mass moving maybe with the lower velocity will just possess a smaller momentum. Since when the mass of the body remains constant in most of the times, the momentum will only change if its velocity changes. So that's how you can see that linear momentum is just proportional to the velocity. In terms, if the mass of the body it remains constant in most of the times, so just altering or changing the velocity will also make the momentum also to change. So that's how it is. Now this law, which you are going to see, the Newton's second law of motion, it explains the effect of the external force on the momentum of the body. The applied force, it can increase or decrease the momentum of the body. So that's how it affects the momentum of the body. The rate of momentum change, it depends also in the amount of the applied force. So that is the Newton's second law of motion. So the second Newton's law of motion, Newton's law of motion states that just the rate of change of momentum of an object is directly proportional to the applied external force, and it occurs in the direction in which the force is applied. In simple terms, you can say that a net force, it causes an object to accelerate, and the acceleration is just proportional to the force, but it is inversely proportional to the object's mass. A larger force, it creates a larger acceleration, while a larger mass results also in a less acceleration for the same force. So that's all I have for this session of the clear. We've seen the concept of linear momentum that directs us to the Newton's second law of motion, and we've seen how you can state the second Newton's law of motion. Thank you.